JEDI is a DA system like multiple agencies are developing, and NOAA included. So, but JEDI including different science elements. So one is really do forward operator, so they really know how to generate the model state on observation space. So this work is really to try to integrate JEDI with METPlus, and then use this to evaluate the atmosphere composition forecast. And then a lot of technical work was done by Wei here. So I'd like to acknowledge this project is really joint center, and then your medicine, Wisconsin Medicine's team, and then also we're including scientists from NCAR and NCEBIT, and then Air Resource Lab. And the funding is from the JPS Proving Ground and Risk Reduction. So the background is that METPlus is a verification and validation package for the UFS. But right now, they still have quite limited capability to verify the chemistry forecast. Right now, METPlus can evaluate AOD and ozone and surface PM. However, really, in the satellite era, there's a lot of satellite observation, but the system is not able to really take advantage of the new generation observation in the space. So, and which, that although there are a lot of very nice ground-based measurement, but to really verify the chemistry forecast, you need all the information, including those from space, and those are really still lacking in the METPlus. So the project is really, we try to enhance the METPlus constituent verification capability by really try to build an interface and allow us to really using the satellite observation from JPSs and from other sensors. So the specific application we're talking about is really cross-cutting verification framework for trace gas and aerosol, and of course UFS application, because METPlus designs for cross-cutting for from S2S to weather to air quality. And then, but why this is important? So really, when we develop model, we tend to compare with observation. So it's very, very important we actually put those model output and satellite in a comparable way. Not just space, not just temporary comparable. It's also, use the operator allow us to consider a lot of sensor properties, so we will not mistakenly, well, I will show later on in the one of CO2 wireless operators to see. When you put in a comparable state, you can do a fair comparison, and that's actually very important when you try to use the results to tune your model. And then obviously, once you advance your METPlus capability by having a better way to compare with satellite observation through the process, you can, the whole idea is to improve the model forecast by learning from the comparison results. So this is an example about in the middle is, in the central panel is a trap-OMI observation, and this show the Siberian Wi-Fi event. And then on the right side, it's we use one version UFS, and then they produce a CO. And now when you don't consider every kernel, you don't consider sensor sensitivity to height. So you will see you get a plume much weaker. So just by actually interpreting results in the wrong way, you will tend to say, well, models tend to be too low. Let's tune the model to big up. But then when we're on the left side, when we consider observation operator, which you consider average kernel, then you actually see we get a higher plume intensity. So that means actually the model is adequate to produce a Siberian Wi-Fi event. But the key is really to really use the observation to tune your model, you need to use observation the right way. And use a satellite operator is really one of the critical way to ensure we can achieve our goal. And then this is, in the Joint Center, we build a Skylab, and this is how we view the data viewers. So on the left side is on the left side is really, after we run a forward operator, we actually simulate observation, use a model state. So this is pretty much what the satellite will see when they sense the atmosphere is actually model atmosphere. And then right side is actually the corresponding observation. So we have this capability right now for multiple sensor for trace gas and for the aerosol. So the whole idea is we want to really bring this in to couple with METPlus for the model evaluation. So that's the framework we're building on. So on the left side, you'll see, obvious to compare model with observation, you bring both information. And then we build a generic interface to read the model state. The JEDI was developed for data simulation, so they actually originally only read model in the natives. So for do every three will be native model grid. However, a lot of time when we do the evaluation, we tend to use the post-processing data, tend to be regularly long or even Gaussian grid. So we actually, the Joint Center developed a generic interface to read those model grid, different model grids, so that allow we use the archive or post-processing results. And then, so once you use this and then observation, we have the YODA data. Well, I guess you want to define. So generic interface was developed to ingest model in any grid format. And then both observation and the model goes through the YODA is how we really read in the observation. And through the forward operator, which is we call the UFO here, and then you can pair model observation and the observation space, which on the right side, the model pair. So in this, so the forward operator will produce a pair model and the observation in a specific format we call it YODA, which stands for the interface for observation data access. So once you create to the point and we build an interface, which is based on Python, to really, that's where we couple with METPlus. So once you got to this point, you pretty much can use a lot of capability existing in the METPlus. So the key is really, you really don't want to reinvent the wheel. METPlus has a lot of very nice capability we want to use. At the same time, we want to verify model use settle observation, and we know that JEDI has a lot of elements, know how to produce the information we need. So this project really try to interface these two elements there, and then for the specific applications, actually for atomic composition. So one example would be here is, so up to this one I mentioned, we kind of cross-cutting from METPlus to the JEDI, which is really from the UFS cross-cutting verification package to the JEDI, which is the DS system. And then we also work on other aspects. Really, there's another verification, Melody Monet was developed by NCAR and NOAA, and that was originally designed for atmospheric composition. So they also, so this is just demonstrating, there's a lot of frameworks, a lot of very nice software systems already there. Sometimes we really just need to make effort to kind of link everything together, and then instead of reinvent the wheel, we can take advantage of existing capability. So on the left side, we run the Melody Monet to pair the WorkCam results run by my group and with a surface observation. So this existing Monet Melody capability. And then we actually, so this will again create a pair model and observation. And now you send the Python interface, you actually call the METPlus now. So to generate those statistics, the continuous table, those kind of statistics, and this is not available in Monet Melody. So instead for Monet Melody to bring those new statistics seen in through those interface, these two very nice package was able to kind of integrate together and for the user's need there. So, so this is one example I will show is actually recent mid-June, the very large Canadian fire that cover the whole Northeast, and that's particular event we pick here. So it's really not to show how good, how bad our model is. It's just show the effort to really combine different software, and because at the end of the day, you had a lot of effort already built on the METPlus, a lot of effort already on Monet Melody, and even JEDI. So really, you really just need effort to kind of interface all together, and then for the really much broader application. So really, conclusion here is we have this project is funded by JPSS, and then the Joint Center, the Wisconsin group, and Ross team, we work together. and to develop atmosphere composition evaluation package, and our specific approach to interface JEDI, their observation process element, which including YODA and UFO with METPlus. But we also connect METPlus with Monet Melody, and that's really, the whole idea is really we want to serve the broad composition community. And one advantage could be, there's certain operators already available Monet Melody, like ARMS, native Maple Ozone, which, so we can, just by interface, then we can use what available in Monet Melody. So this I just want to showcase, we really working on the composition verification framework. It's really cross-cutting, really just not within across the UFS. We really go beyond, because that's where we bring the JEDI and we bring the Monet Melody. So I guess that's what I have. So.
Thanks, Sarah. Dustin, you might as well come up. Try to keep the transition short here too, but yeah, again, I think we probably need to push the questions to later. Next up is Dustin Swales talking about hierarchical physics development with the Common Community Physics Package single column model.
Thanks for sticking around for this. First, I want to thank my co-authors.